Do you hear me? OK. Welcome to my talk about React Native. And, well, my name is Edu, and you have my Twitter here. I work in Plain Concepts, which is a Spanish-based consultancy firm. I'm based on the Barcelona office, and for me, it's a big pleasure to be here in Amsterdam, talking about React Native, what is, what isn't, and how we can create mobile applications using JavaScript and the same workflow and tools that we use to build web applications. That's the goal of the talk. So first, exactly what is React Native? This is the first question we need to answer. So basically, React Native is a library to build mobile apps. So it's the new brother of ReactJs, which is a JavaScript library used to create web applications. React Native is designed following the same guides of React and is built for creating mobile applications, Android and iOS. These applications will have a native UI, so that's an important thing that we need to recap. We will use JavaScript to build our application, but this is not like Cordova, so we will have a native UI. The controls that we will see on the screen will be native UI controls. And we will use JavaScript as a language and the same workflow and tools that we use as a web developers. So basically, React Native is intended for web developers, allowing them to easily create mobile applications with a native UI. That's the goal. So if you are web developers and you work with like typical web developers tools like NPM, Grunt, Gulp, Webpack, and JavaScript as a language, you will be very familiar with this workflow, and you are ready to start creating mobile applications using React Native. But these aren't the most important things about React Native. So we have a JavaScript library to create mobile applications using JavaScript that will have a native UI, using the same tools and workflow that we use to create web applications. But these are not the most important thing. The most important thing is that React Native brings the React way to the mobile development. And this is important because probably ReactJs, when it appeared, was one of the biggest things that happened in web development last years. And React Native brings the way how we think about applications and will allow us to build web applications using this kind of thing. This is what I call thinking in React. I use a chess background because thinking in React, React is like chess. So it's easy to learn the basics, but it's hard to master it. Okay? But if we want to really use React well, we need to start thinking in React, which is very different that we use to build other kind of applications. There are three key factors that we need to remember when we develop in React. React Native or ReactJs, it doesn't matter. Philosophy is exactly the same. The first is there are only components. We have nothing else in React Native. We only have components. We will create our applications based on components. So if we need a screen which is showing a list of beers, we will have one component will be the entire screen, another component which be the list, and another component which be each item that we are showing in the list. And the only thing that we really have is components. We don't have anything else. We don't have things like controllers or models and so on. We only have components inside the library. The other key aspect is what we call the single source of truth. Components in React Native, in ReactJs, it doesn't matter, have what we call properties, which is an immutable data of the component. So it's a data when you create a component, its properties can never change. And components also can have a state. A state is the mutable data, the data who can change after the component is created. The single source of truth, what it says is that every data that your application is dealing with should only be in one state of one component. Because if you have the same data in 2 or more states, what you are really having is a stale data. And you don't know exactly which of the 2 states has the real data. What happens if one state changes and the other don't? You will have different values for the same data, and this is very dangerous. What makes React simple and powerful is following the principle of single source of truth. Probably the most common anti-pattern when developing in React is the unwanted state, which is very usually when one starts to develop in React to put a lot of things in the state. And basically, React tries to avoid, we need to avoid a state as much as possible. We will see later how we can do that. And the third key factor is the one direction data flow. So that basically means the data in our application only should flow in one direction, which is from top, from the parent components, to the bottom, from the child components. But data never should flow from child components to parent components. That basically what it means is that we won't have any kind of two-way binding and so on. We will only have a parent component. We will be responsible for the data of our application, and our parent component, what needs to do is to pass copies of this data as properties, immutable values, to its children components. This is the way that we need to start thinking applications. Can be hard at the beginning because it's a new way to think about our relationship between views and data, but it's a very powerful way when we start to thinking at this point. This allows us for a reusable stateless components. This is the mantra of React. This is what we need to achieve. We want to create a stateless component. And a stateless component is basically a component that does not have a state, only have properties, only have immutable data. Once the component gets and displays its data, this data displayed by this component can never change. If we do that, our component is a stateless component and is very, very, very reusable between applications, between components, whatever we want. So basically, avoiding a state in your components not only make them reusable, but we can also save your life, because this makes components very easy to test, very easy to predict, and very easy to debug. And the three are three important things. And a state should be stored in a single point in our applications, which is basically following the principle of single source of truth. We need only to have one point in our application where I have the real data. The rest of components of my application, what are showing, are copies of this data. And they should be an immutable copies of this data, so we need to use the properties of our components, which is that component should only have real access to this global application state. Of course, data changes. When you are running an application, data is changing. If you have a text box and you enter value in the text box, data is changing. If you are fetching some data from a server and displaying whatever you want, data that you are displaying is changing. we will see how React promotes the one direction data flow, but because we need to keep in mind that when we change the state of a component, what really happens in React is that this component is discarded, okay, and a new component with the new state is created. When a component is discarded, all its child components are discarded also. So basically that means that if we change the state in a top-level component, each change in this state will discard the entire component tree. This maybe sounds that this should be a lot of slow, because you are changing the entire page. You are discarding the entire page, everything that the user enters, for example, a keystroke in a text box. But this is not what really happens under the hood. It's what really happens for us. But components in React do not interact directly with the UI. So basically what really happens is, imagine that we have a top-level component within a state of our application. This top-level component has so many child components, and one of these child components, using a callback function of the top component, we will see an example later of that, changes that state. In this case, the state we changed is the state of the top-level component. That, from the point of view of React, means that the entire top-level component is discarded and replaced with a new top-level component containing a new copy of the page with the new set of data. And this is what happens in JavaScript. But when the runtime of React needs to re-render this new top-level component, what he really does under the hoods is compares the real UI with the new generated UI and makes the diffs and only updates the UI in the best efficient way. So this can sound complicated, but what it means is React is fast. React is very fast, but this is not its very big advantage. You will, specifically in web development, you can see a lot of comparisons between React. React is fast, so Angular is slow, etc. This is not entirely true. If you really tune an application using Angular, can be as fast as an application using React. And if you do not use Angular nor React and use vanilla JavaScript, your application can be even faster. What is really interesting about React is that makes these things very, very, very easy. Maintaining the state of our application will be a very easy and simple task. And what about the architecture of React Native? Okay, the whole story has first appeared ReactJs, and some months later appeared React Native. First, it's not really a write-once solution. So it's not really a solution I only write once my application, and then I can run my application on iOS and on Android without any change. At least not yet. Okay? Why? First, the JavaScript code can be really shared. So our business logical code, our data access code, whatever, can be easily shared with the iOS project and the Android version. But the UI code is not totally reusable, because most of the components are shared between Android and iOS, but not all of them. So we have components only for iOS, we have components only for Android, and maybe we need to create two versions of our screens, one for iOS, one for Android. Approx, in a project of mid-complexity, approx 70% of the code can be shared between the Android and the iOS application, and you have a 30% of code that needs to be specific for each platform. So really, it's not a total write-once solution. Okay, important, the UI is fully native. Virtual DOM is a key aspect in React Native, also in ReactJs, which basically is this virtual UI that are generated by our components. And what the React runtime does is comparing this virtual UI with the real UI that is shown in the mobile and update the UI of the mobile using the best efficient algorithm. Okay? But we need to have this clear. A React Native button is really a UI button in iOS, or is really an Android widget button in Android. So we will have a real native UI. And what happens about JavaScript? Because we will code in JavaScript, but Android and iOS do not run JavaScript natively. JavaScript is bundled in the application package, so it's not compiled. We won't have an ahead-of-time compiler or something like that. JavaScript is deployed with our application and is executed using JavaScript core. If we don't know, JavaScript core is a library, an open source library, part of the WebKit project. And this library, what allows you is to run JavaScript in any application. Is a runtime of JavaScript. So all JavaScript code we use to create our application will run using JavaScript core. JavaScript core is part of iOS. So every iOS device has a JavaScript core by default. This is not the same with Android devices. So the React Native version of Android has its own version of JavaScript core, specifically designated for Android. JavaScript, this is important, JavaScript runs in an asynchronous way, so do not run in the same thread as the UI thread. That means that basically our UI thread won't be freezed when our JavaScript code is running. Okay? Because React Native will run our JavaScript code in another thread. Of course, React Native, its runtime, needs to call real native methods that the underlying iOS or Android. And if React Native performed these calls one by one, this will be very slow because we have a payload at each call. We need to serialize. We need to translate between the JavaScript environment and the native environment. So what React Native do is try to bundle a lot of calls in the same pass from the JavaScript code to native code. So this is try to be as efficient as possible. And when a JavaScript method needs to call a really native method, they never share data. They never share a mutable data and a struct in any position of memory. What they always share is a serializable immutable message. So we have copies of the data that are traveling between the JavaScript world and the native world. So we need to understand this, specifically when we want to extend React Native and create native wrappers from the things that maybe React Native still don't have. And what about styling? Because in web, we have CSS, but in mobile, well, a style an Android application is absolutely different than a style an iOS application. What React Native offers us is a custom implementation of the CSS. Okay? We won't have CSS files. Our styles will be defined in a JavaScript object, and the properties of this JavaScript object are the same properties that we use in the CSS. Really are a subset. Okay? JavaScript native does not support the full CSS standard. Should be something like that. So here we are defining two styles, container and depressed. As you can see, this is very similar as we will use CSS in a web application. And then we apply the styles using the style attribute. Okay? And what about layouts? This is a thing that's very different between Android and iOS again. what React Native offers us is a custom implementation of the Flexbox standard in CSS. So we will have a layout system that we can share in our iOS and Android application. We need to understand the concept of what we can call functional UI, which basically that means that we can start thinking in our UI in terms of functions and not in terms of methods that are rendering things. Okay? So basically, that means that our UI, we need to be able to modelize our UI as a function that takes some data as an input and returns our UI as an output. This is basically a React component. In fact, in the most simplest form, a React component is a single function of JavaScript. Okay? So imagine this a screen. This is just a label with a counter and the button to increment this counter. So basically, we can see that the UI is the function passing the count value. We need to render. Okay, and this function this is a web applications. Philosophy in React Native will be the same. We'll see is a div with a span with a button. This is thinking in terms of functions. And what happens in terms of code? This is React code. OK, a bit weird. What the hell is that mix of JavaScript and HTML code? OK, as you can see, this is JavaScript code. This is stored in a .js file. Okay, so we are mixing JavaScript and HTML. This is a syntax of React and React Native, which is called JSX, which allow us to do this mix. But JSX is transpiled into pure JavaScript. Okay? And this is basically how we will create a component in React or React Native, because it's exactly the same. There are no differences. The only mandatory function for every component is the render function. And what need the render function do? Need to return the virtual UI for this component. Using what? The properties, which are stored in the this.props, and the state, which is stored in the this.state. And in this case, we are using the this.props.counter to render the current value of the counter. If we have this kind of component, this is in a stateless component, as you can see, because we are not using the state. So this component has no state, only has an immutable value, which is counter. We can create the same component using a pure JavaScript function. Both forms are equivalent. Okay, but if our component is a pure stateless component, we can represent it using a pure JavaScript function. If we try, of course, if we try to run that in React Native, we will find this red screen of death, which is the error page of React Native. When something goes back, we'll see this red page. Why? Because React Native does not understand about diffs and spans and something like that. But React Native understands about these other components. This is the React Native equivalent component of the previous one. Instead of a P or a span, we can use a text. Text is a React Native component that basically renders a label. Touchable native feedback is a React Native component that wraps a view and makes it to respond to the touch event. Okay, so it's a way to create a button. And the content of this button will be a view that will have a label with @+1. If we run that in the emulator, now we'll see our React Native application. But as I said before, a state changes. So basically, what happened when we press the button? Okay? So when we press the button, we want that the counter increment its value. 1, 2, 3, 4. OK. need to remember that a state should be on a single place, usually in the topmost component. So we'll create a new component. And this is what we have. Basically, we have the counter page, which represents the full page we are representing, or the full view in our application. And this is the component that has the state. The state, this is the mutable component. This component has a state with an initial value of 1. And this also have a function which is on counter tab, which basically this function, what it does is update the state of the component. Remember, when the state of the component is updated using the setState function, the component is discarded and replaced with a new component. Okay? And this component, what basically is rendering is a view containing the counter component that we created previously. So counter page component is a parent component, and counter component is a child component. A state is stored in the parent component, not in the child. And how the child component can say to the parent component that the button has pressed using this property on tap, which is defined in the properties. Basically, everything, every attribute that you passed in the JSX tag is a property of the child component. So here we are passing a counter, so we will have props.counter. Here we are passing on tap, we have props on tap. And the only thing we are doing is binding the onPress event of the touchable view component to the onTap property. And what is the onTap property is that function of the parent component that changes the state and forces a full refresh of the page. But remind that when I say a full refresh of the page is from our developer's perspective. But what really React will do is compare the real UI with the new virtual UI and update the real UI in the most efficient way. Okay? So that is really working. Okay, this is exactly what we have said. Important, counter is still a stateless component. And this is what we want. We want a state in the topmost components, and all child components should be stateless components. This is one direction data flow. Why? Because the data, which is the value of the counter, only flows from the parent component to the child component. Data is never updated by the child component. The only thing that child component do is invoke a callback in the parent component, and this is the parent component who is the responsible for the data to update its state. Okay, let's see this in action. If you want to see how this is working, I have exactly the same things here. Okay, this is the React Native project. When you install React Native, npm install React Native, you get the command line interface of React Native, and you create React Native init, and the project is the way to start a new project. What React Native init do is create a basic scaffolding of the project. And this basic scaffolding basically contains an index iOS and an index Android. Okay, and this is, well, here I am using the ECMAScript 6 modules. This is the main page. Okay, this is the main component. This is created by the scaffolding with the basic styles, which are created by the React Native init. This is the counter page we had previously, and this is the counter. Okay, and how can I start that? I go, where is the project? I use React Native start. This is to start the package bundler. This should start automatically, but in Windows doesn't. If you have a Mac or a Linux, you don't need to do that. Okay, this is a bug in the Windows version of React Native. This is the package bundler. It's the equivalent of Browserify and Webpack. It's the system that creates the JavaScript bundle and minifies it, and so on. Okay, and when I have the package bundler installed, I just can use React Native run Android or run iOS. Okay, here I have the Genymotion emulator for Android installed, and he's compiling the application. Okay, important. As this is a native application, really, you need to have installed the SDK for Android or the SDK for iOS in your developer machine. And here I have my application running, and when I press the button, the counter is increasing. So it's really easy to create these applications. But an important thing of React, remember, is that we can use the workflow that we use to create web applications. And the workflow of web applications is that I edit JavaScript, press refresh on the browser, and I see my changes. I can do exactly the same. So I can see, I can use that, I can save, I can go to the menu and reload, and I see all my changes in the application. No need to recompile again, no need to do nothing of that. Okay, so I use the same workflow as I use to create web applications. Even though I can debug this. How? Using Chrome. Again, using the button, I can debug JS. This will launch Chrome. Okay, and here I have the debugger tools. I can go to where my code is, in this case in the counter.js, and can put a breakpoint in the render, go to the emulator, push, and my code is stopped in the breakpoint of Chrome. And I can use the same tools that I use to create web applications to debug a native UI application created using React Native. This is the important thing. It's the same workflow that we use to create web applications. Okay? This is exactly what we have told. We don't need to do all those things in React. We can debug the code using Chrome. And with navigation, what happens about navigation? This is a very trivial example, what I shown you, but a lot of mobile applications have more than one view, and you can go between views. Okay, this is handled using a specific component, which is the navigator, which handles all this stuff. Okay, and this component offers an API which is similar, not equals, but similar to the push state API of HTML5. It's an abstraction. It works both in Android and iOS. Okay. And basically, the way working with navigation is that we will have a topmost component for each view of our application, and we can use an API containing push, pop, and something like that to navigate between pages, which are really React components. Okay, it's powerful and easy to use. There's another legacy component which is Navigator iOS, which only works on iOS. And the difference between Navigator and Navigator iOS is that Navigator iOS uses the underlying navigation controller that the iOS has, and the Navigator don't, because it's cross-platform and tries to emulate the behavior of Navigator controller in pure JavaScript. Okay, and finally, okay, we have talked about components, but what happens when we need to access some native APIs? For example, I want to store something in the storage of the mobile device, or I want to access to the camera roll, or to the battery level, or to the vibration API, or whatever. Fortunately, React Native offers us some wrappers for these native applications. Okay, so these are only some of the wrappers we have. Okay, an app state for getting notifications when our application is in the background or foreground, a sync storage to store files in the mobile, a camera roll to access to the camera, vibration to access to the vibration API of the mobile, a fetch, which is an API to create HTTP requests, basically, geolocation, which allows us to access the geolocation API, and so on. There are a lot of these APIs. Not all are cross-platforms. Some of them only exist on iOS. Some of them only exist on Android. Most of them exist in both platforms. Okay, but we need to be careful about that. And typical questions when we reach this point is, can I interpret with native code? Yes, you can create a native module, which is the way that we can extend React Native. So if we need to do something using pure native API, we can do that. We can get Android Studio, we can get an Xcode, and we can create a class which needs to conform to a specific protocol on iOS and needs to extend to a specific class in Android, and then automatically React Native is able to invoke this native code. So we can extend React Natives with native code if we need so. And we can also wrap native UI controls in a component of React Native. A typical example is show the MK map view of an iOS application inside a map component of React. Doing that is not easy. It requires some knowledge about internals of React Native and mobile development, but the key factors are, yes, you can expose native UI controls to JavaScript. We can bridge native properties to JavaScript, so we can set a property of our React Native component that is in JavaScript, and this property is a native property of the underlying control. And we can dispatch events from the underlying UI control to our JavaScript code. So we have fully potential on this side. Okay? And basically, that's all. If you have any questions. Sorry, I have a... Whoa, but I won't read you, I think, so... Whoa. Whoa. No. Whoa.
Yeah. So when you're debugging, inside this, so you started debugging. When you're looking at that interface, so through the Android emulator, are you looking at real native components then, or is it JavaScript objects that you're looking at?
No, are real native UI components.
Okay, so
okay.
When you build,
yes.
It will be in the end the same kind of objects you are looking at in the emulator.
Yes. An important thing, but is when you debug, as you use Chrome to debug, the JavaScript code is not interpreted by JavaScript core library, it's interpreted by V8. So it can be slight differences between how JavaScript core and V8 interpret your code. Okay? But behind that, it should be the same.
Okay.
Okay, thank you.